What's going on, guys? Today I'll be going over lecture 8. We'll go over spectroscopy, the Bohr model, quantum numbers, and orbitals. But first, a fun fact. Did you know that a cat has around 20 to 30 grams of protein per 100 grams? It's very similar to chicken. Anyways, in spectroscopy, there is the Lyman, Balmer, and Paschen series. Spectroscopy is the study of the absorption and emission of light and other radiation by matter. The Lyman series is considered to be high energy. Using a hydrogen atom, an electron from higher energy levels, greater than or equal to 2, falls to the first energy level, which is 1. The transitions result in the emission of light in the ultraviolet or UV range of the electromagnetic spectrum, which has short wavelengths and therefore high frequencies. The Balmer series refers to transitions in the hydrogen atom, where an electron falls from higher energy levels, greater than or equal to 3, to the second energy level, which is 2. These transitions result in the emission of light in the visible spectrum, which we can actually see with our own eyes. The Paschen series results from transitions in a hydrogen atom, where an electron falls from higher energy levels, n greater than or equal to 4, to the third energy level. These transitions produce light in the infrared IR region of the electromagnetic spectrum, which has longer wavelengths and lower energy compared to the ultraviolet Lyman series or visible light, the Balmer series. The Bohr model, developed by Niels Bohr in 1913, is a way to explain how electrons are arranged around the nucleus of an atom. According to Bohr, electrons move around the nucleus in specific fixed orbits or energy levels. These orbits are circular and have a set size and energy. Each orbit corresponds to a specific energy level. Electrons in different orbits have different energy amounts, with electrons in higher orbits having more energy. Quantum numbers are values that describe the properties of electrons in an atom, which makes it easier to understand their position and behavior within an atom. The principal quantum number represents the energy level of an electron and the size of the orbital. Going from 1 and beyond, higher G values of n means the electron is farther from the nucleus and has higher energy. The angular momentum quantum number defines the geometric shape of the region in which there is a high probability of finding an electron. It is also related to the electron's motion around the nucleus. Each level has a corresponding orbital. The magnetic quantum number represents the orientation of the orbital in space. The values go from negative to positive L, correlating with the orbitals. The spin quantum number represents the intrinsic spin of the electron, and it only has values of negative 1/2 or positive 1/2. It indicates the direction of the electron spin, which creates a tiny magnetic field. Finally, orbitals are regions around the nucleus of an atom where there is a high probability of finding an electron. With each orbital, the value L, or angular momentum quantum number, increases by 1. The s orbital is circular with a L value of 0. The p orbital is shaped like a dumbbell and its level is 1. And the d orbital is cloverleaf shaped.